Hello everyone. So in today's lecture, we'll see what closures are. So closure is basically not a React concept. Here you can see it is not a React concept. It's a JavaScript specific concept. So what closure basically is, it is a feature in JavaScript where inner function. Okay, so we have a function, and inside that we have another function. So inner function has access to the outer enclosing functions variable. So this function has access to all the variables of this function. Okay, so let's take an example of this. Here you can see that I have written the code in JavaScript. So what you can do is that open a JavaScript file and copy this code, or let's intuitively write our code. So what will happen is that whenever a function is called, all the variables are created inside the stack heap. So let's say if variable x is called, so x is created in the memory, then y is called, then y is created in the memory as long as function is there. Okay, when the function execution is completed, all this is also deleted from the memory. So let's see how this works. Here you can see I've created a JavaScript file. So let's create a function. Uh, let's say outer function. It has a variable let a equals to uh, 10. Then we create an inner function inner. It has a variable b equals to 20. What we want to do is sol.log a plus b. All right. And then what we want to do is we want to return inner. So here we can see that our flow is going to be, first our function outer is will be created, then in outer function a will be created and stored in that memory, then another function b will be created, inner will be created, in that b will be created, and then what will happen is that a plus b will be logged and we will get read. So here you can see that I have outer function, in that I have defined a, then I have inner function that is inside the scope of outer function, in that I have defined b. Then what I'm doing is I'm logging a plus b and then returning in the scope of outer function, I'm returning the inner function. All right. So let's go to our theory. So what should happen is that first our outer function is called. All right. So let's say this is our memory and this is outer function. Okay. So what will happen is that a will be created here. So this will be a. All right. After that, inner function b will be created. So let's leave this. Let's make some dotted lines for that. All right. This is a function, and inside that function, another variable b is created. Okay. B is created, and this is out function, and this is inner function. Everything inside the dotted line is inner function. I and function. All right. And everything that is outside is called outside function. So what happens is that, let me change the color. So in JavaScript, what happens is that whenever there is an inner function that has a variable declared in itself, but also required a variable that is defined outside it, but is in the scope of its outer function, or what we can say is in the lexical scope. So here we can see that the inner function is inside the lexical scope of outer function. So what happens is that a is transferred to a's value is also transferred to b. So in this variable, so in this scenario, what is happening is that our inner function is this, but if it wants, it can also access the value of a. Why? Because inner function, or this inner function, is in lexical scope of the outer function. All right. Yeah, let's do this. It's in the lexical scope of the outer function, or better it will be like this, not like this. Yeah, like this. Okay. So here you can see no matter how many times a function is called, when the compiler enters the function, it creates a variable x, initializes its value to 10, then adds 20 to x, and x is returned as 30. Once returned as 30, the compiler exits the code, the variable x is deleted, and then above cycle repeats again and again when the function is called. Okay. So what is happening? When the function is called, a variable is created. Okay. Function is called, variable is created. As soon as the function calling or compiling completes, entire thing is deleted. Okay. Yeah. So during the compilation, let's suppose we call outer. So outer function will be created, memory will be stored a. Then when the execution is completed here, what will happen is that this will be deleted. All right. So let's see the closure working in succession. So what we will do is that we will call the outer function. And what this outer function is going to do, it's going to return us the value of inner. Okay. So what we'll have to do, we will have to store the value somewhere. Let x equals to outer function. Let's see what happens when we console log it. Log x. Okay. Here I'm using node environment. It is a JavaScript runtime environment. I pressed F5 to execute the code. And here you can see that when we call the outer function, it returns of inner function whose value is stored in x. Now what we can do is that when we call x, I want you to pause and just think what will be the value of this. So do you think like it will be undefined, or do you think that it will actually get the value of a? So If you said that it will actually get return as the value of console.log a plus b, then it will, because let's see. All right, here you can see the value 30 is printed. So even though we have only defined b as 20, but still it is getting access to a variable that is not defined inside the same function scope, but it is defined in its lexical scope, that is in its parent scope. Okay, we can also do this dot log a and again run the code. Let's actually remove this console because I think you get the point, and let's rerun the code. Here you can see we have console logged a, so 10 is logged here, and then we get 30. But same thing is not true. So like if I try to access dot log b here, then it won't happen. Okay, see it is giving us a reference error that b is not defined. But okay, yeah. But when I'm calling the inner function, so it is not giving us a reference error that a is not defined. This clearly defines that a or the inner function has access to its external variables or variables that are created outside of the its scope of inner function, but inside the scope of its parent or lexical scope. Again, let's rerun the code, and here we should have 10 and 30 again. So here you can see even though we are console logging, we are calling the line 16, we are calling the function in line 16, still it is logging this a plus b. So this is how the closures work in JavaScript. So this is not a React specific concept, hence we have not created a JSX file, we have created an app.js file. So let's go to theory. Right now in some cases the outer function does not execute, then b is not created, and in such case you will get value of a plus b will be printed. Here we get the concept of closure. This is just what we saw now. All right, so let's store the value of outer function. This is what happens. This is, so this happens, so because of flow, this happens because of closure. So here b is not defined within the inner function, but inner function forms a closure over the variable in its lexical scope, the scope within which it was defined. Okay, so our inner function was defined in the scope of outer function, which includes b from outer function. So whenever a function is created, it has access to its parents variable as it forms a closure over the variables in its lexical scope. All right, this is an important point to note. This, right, this is an important point to note. This is very useful in React and in JavaScript. So yeah, keep this in mind, because it actually, what closure does is that it actually re-renders our UI. So a closure is a JavaScript. Again, here I've defined the given the definition. So this is like a conclusion. So a closure is a JavaScript feature where an inner function has access to its outer and closing function, and this allows the inner function to remember and continue the access the variable. These are the key characteristics of closure: access to outer functions variable. We have seen this in form of B. All right. Then persist and scope. The variable in the outer function scope persists as long as the inner function exists. Okay, so as long as we have the inner function, the outer function will also execute, or will actually have a reference, okay, to the outer function. Then encapsulation provides making it possible to create private variables or end functions. So here you can see now again, if I go come back here and define let a equals to 10, and here I, or a equals to, let's give it as a string Optimus Prime, and then I again console.log a, and then I run this code. Here you can see what happens is that I have Optimus Prime, then I have 10, and then I have 30. All right. So here I have 10, and then I have 30. So what happens is that a is defined twice in our code, but a here is a private variable only for outer and inner. So once the execution of outer and inner variable inner function is completed, a will be destroyed from the memory of these functions, and then it will again return to the memory of the code. So here you can see that we have created private a and b variables. Important. In closure, inner function maintains reference to its lexical scope. Again, we have seen this maintains a reference. This is important. Okay, again, not a new a variable is not created. What happens is that it maintains a reference from to its outer variable, right? Yeah, which includes outer functions variable. The reference is kept alive even after the outer function is finished executing. So yeah, this was all about closure, and now we can see how re-render works. So here we have this whenever we declare the state, we have this line. All right, so let me just go to any of our code, so we can go to the code of our like button. So let me jump there. So this is our project, and whenever we click, this like button changes its value that we have seen in the last video. All right, so what happens is that counter.jsx, or consider this as our like.jsx, like.jsx. So whenever our component set count is called, then our entire component is re-rendered. So in our case, when our set like is called, our entire component is re-rendered. All right. So what this line does is that, sorry, what this line does is that it initializes or gives initial value to anything, our variable. Okay. So in our case, the initial value for our variable like was false, that our post should not be liked on its own. So let me show you. So let's say I click the like button. All right. When I refresh, again it will go to unlike state. Okay. This is our initial state. Then when we click on set like, okay, so set like, what it will do, it will set the value of like to not of like. So if value of like is false, then it will set it to true. If it is true, it will set it to false. So true, false, true, false, true, false. This is how it's working. All right. Yeah. Once everything is initialized, this state declaration line is ignored and React component is rendered. So once our state is initialized, okay, so what will happen when our component is re-rendered? What React will do is that React will ignore this line. So when it enters the scope, it will directly start from here, return this. When there is some change, it will again go back to this method, again do this, again any change, it will go back here and do the changes. Okay, you can add a console log component is re-rendered. This we have seen in the states video. Okay, see, see, this is happening because I'm using my mouse. Every time the increase count button is clicked, the console we can see component is rendered. So what we can do is that we can actually add here console.log, and here we can go component was re-rendered. Let's see what happens. See, whenever I'm clicking, component was re-rendered, component was re-rendered, component was re-rendered. This is what we have done effectively. Here it is defined for count. We have done for our like. Okay. So when component is rendered for first time, the value inside increase count is 0. So here we can see here our initial value is 0 for counter case and false for this case. When we do this, let's say we have rendered it 4 or 5 times, and now when we again refresh it, so initial value will again go to false. So this is a dry run. So initialize, our counter will be 0. Component is rendered exactly 0 time. So this means the initial state is used. Then when we click on the counter for the first time or our like button first time, increase count method is triggered. In our case, change like button method is triggered. Console log inside prints 0. Console log prints component is re-rendered. Set count changes the value of count with count plus 1. Set like changes the value of like from if it is false to not of false, that is true. Set count re-renders the component with increasing in count. Set count re-renders the component with value change from like to unlike, like, unlike, like, unlike, like, unlike. That is all. So in the re-render, there are two stages. So in first stage, our increase count function increases the value of count by using set count plus 1, and then render state where entire component is re-rendered. Okay. So first stage is that this method will change the value of variable declared here, and then in second, what this method will advise React or command give command to React is to execute the entire code again. Right. Yeah. All right, so let's move on to the next concept, that is callback in an updater function. So this is basically the concept that is going to tackle that how are we going to change the value of our variable when the new value is dependent on the old value. All right. So what we can do is that we can give callback to the new value through the old value. All right. So what this will do is that in our increase count method, we want to increase the counter by 2. Then what we can do is that we can logically think that we want to call the set count method twice. So if we want to change the value, like if we press 2 times, then only the like should be changed. So we cannot do like this. All right. This will not work. This is not the logical thing. So what we want to do is that this will, first of all, this will not work because as I told you, this set like function is an asynchronous function. So yeah, here we have seen that it will not behave predictably because it is an async function. Important. All right. Let me mark this like that. So if you want to screenshot, And we know what we do is that we use async functions in our callbacks, or we use callbacks in our async functions. Okay. So there are two cases. So what updater function does is that it will update to any arbitrary value. Okay. So in first case, let's see the simpler one, any arbitrary value. So if the value of x is 25 right now, and we want to set it to 50, okay, then we want to set it to 63, then 71. Okay. So these are just some random arbitrary values. So what we can do is that we can directly pass this value to the updater functions. Okay. But let's say we want to add in multiples of 25. So 25 1, then the next value will be 75, then the next value will be 100, and so on. So what we will have to do in that case, we will have to use the callbacks, okay, updater function. Then we'll have to use this callbacks method. So let's see for our like example how it is going to work. So what we want to do is that let's do one thing, Control X. So the current value of like is going to depend on some other value. Okay, so what we are going to do, so for current value of like, what we are going to do is that we are going to return some other value, and here again what we'll do is that we'll just change the value of current value of like. So this is going to do the same effect as our not of like, but this is a much better way to do it because it is using the asynchronous nature of JavaScript. All right. Yeah. So let's see if there are any changes in our code. Let's refresh. Okay. Everything is working the same. So yeah, this is basically what is callback, or yeah, this is the callback in updater function. Yeah, so this is just a theory. Now, this is some more information about state. So as I told you, re-rendering will only happen when React detects any changes in the state. So it is not like this component is going to be re-rendered. So whenever it is seeing any change, only then it is re-rendered. Okay, so if we are changing the status of like button, only then it is re-rendered. It is not like it is going to be rendering at regular interval. Initial state is rendered. Okay, so this is our count for our example of like. Initial state is going to be false. Okay. So in case of async callback, our component is re-rendered as the count variable is changing. We have already discussed this in our lecture or in our video. State declaration line is basically the const like set like. All right. Here we can see that we have declared an init method, and init method will set the random value for the count. So inside the user state, we are calling another function, and then that another function's random value is set here. Okay, so this is actually a really cool example. Let's do this. What we'll have to do is that we have the counter anywhere here. We do not have the counter. Let's do one thing. Let's go to ChatGPT. Write me a code for simple counter in React. Till then, what we'll do is that we will create a React file or JSX. All right. Let's copy this code, and let's go to our app.jsx. And here what we can do is that we can call counter. Let's copy this counter and call this. Let's see what is rendered on our page. Okay, a simple counter, increment, decrement, reset, increment, reset. Okay, this is a simple counter. So what we want to do is that we want to set the value of counter initially to some random number. Okay, so here we can go in counter.jsx. Instead of 0, what we can do is that we can set it to math.random, and then yeah, math.random, and then what we are doing is that we are setting the value as count plus 1. Again, you can see inside on click we are using an callback function. So callbacks are really important in JavaScript. So let's see the result. Let's see what happens. Okay. So our initial count value is this. Now when we are incrementing, here you can see only this value is changed. Again, 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 again. When we are decrementing, it is reducing by one, right? So here you can see initially only one random value is given. Not this random method is not called each and every time. Once the random method is called, after that only one is used, right? So this is actually what it is written in theory. So this is why it is important to do the practical thing, because theory in this big letters or big paragraph, the theory is written and you get intimidated by that. So instead, it is just easy to start practicing this. And sometimes you can also use ChatGPT. I mean, you saw how easily it wrote the code for this simple counter. Then we can again reset it. So yeah, this was all about states and closures and callbacks inside the updater function. And thank you for watching till the end.